Hello students, I hope you're doing well. I wanted to spend some time talking to you about doing straight line extraction. This is on page 62 of your lab book. This is laboratory 10A, I believe. And I just want to show you the process I do the straight line extraction so you can understand how to calculate the total resistance and then the voltage drops and how the current runs through the circuit. So I'll take this circuit and then I go through and I actually take a sheet and I'll draw my information there to figure this out step by step. So we're going to take this circuit and I'll just draw my straight line above there. And what I'm moving, going left to right, is I'll work on this circuit, and I'll start from the positive side of the circuit, or the negative end of the circuit over here on the left, and go through towards the right. So what I'll do is the first thing I have here is I have a 1,000 ohm resistor in this very top branch here. Then right after that is a 270 ohm resistor. So I'm just redrawing the circuit into a straight line. I'm replacing the schematic symbols with just numeric values. And very often I'll use color codes just so I can know the difference between, by looking at the colors of the voltage and the current and the resistance. So 580 on this bottom branch is in series with 820. So all I've done is I've just redrawn this part network here between these two, between here and here. I've redrawn this network to show my resistances there. And then if I look here at the end of where this 820, 680, and 820 come, if I follow that around, you'll see that it goes down here to this bottom branch, or this other branch. It goes to the positive end of the power supply. And so I have 150 here, and it's in series with 330. And the 330 is the positive end of the circuit, and this over here is the negative end. So now what I want to do is go through here and calculate all the numeric values. So what I will do next is I will look at this part here, and I will add these up. I'm going to add this top branch and this bottom branch. So I get 1270 here, these two added together, and then my 680 is below it, and then I add these two here, the 560 and the 820, and I get 1380 here. And then I have the 150 and the 330 out here to the side. We'll add those up in just a minute. Now what I need to do is I need to do the math for this. This is simply what I call the inverse of the inverse. So I take the inverses of these three resistors in parallel, add the inverses up, and then I divide that into 1. Or sometimes what I'll say is the inverse of the inverses. And when I do that, my resistance for this network here becomes 335 ohms. When I get to that part, I add 335, and I'll go ahead and add these two, 150 and 330, and that's 480 ohms. Then when I add these two together, my total resistance is 815 ohms. So that's how I get my total resistance, going step by step through this straight line extraction process, or linear extraction. My voltage in this case, my applied voltage on this one is going to be 12 volts. So we'll put 12 volts there. And we're basically using Ohm's law to do all these values here. So I'm using volts is equal to I times R. And then I'm using resistance is equal to voltage divided by current. And I'm reading current is equal to voltage divided by resistance. So we're just using these derivatives of Ohm's law in order to calculate all these equations we're going to do here. And sometimes I'll color code these just so I can keep them straight. So if I take this 12 volts and divide it by 815, my current's going to come out to be very close to 15 milliamps. It comes out to be 14.7. Okay, so there's my 14.7 milliamp. I take one step above here and I put my 14.7 milliamps there. And now I'm just taking my voltage drops is going to be equal to my current times my resistance. So this 14.7 times 330, 14.7 times 480. I get my drops there. And those drops in this case are going to be 2.2 volts. So I have 2.2 volts. I'm sorry, I have 4.92 volts here. So 4.92 volts here. And then over here on the 480 is going to be 7.06. And then I move this up to this up here. So I know my current here is the 14.7. And I know that my voltage drop over here, the voltage drop over here on these three resistors is 4.92. And so we use Ohm's law again to calculate the drops here. The drops on my 150 and my 330. So I'm simply using Ohm's law, the 14.7 times 150. And the 14.7 times 330. And this becomes a 2.2 volt drop on the 150. And this 330 is going to come out to be a 4.85. And then I figure out the current for these three branches here. So 4.92 divided by 1270. And when I do that, get a 3.9 milliamps on this top one. 9 milliamps. And then on the 680 I get 7.24. And then on the one that is the 1380, I'm going to come out over there, is I get a 3.56. So you see the reason I color code is it gets pretty messy when I go through here and try to figure all this stuff out, so it helps to color code it. Now we need to figure out the drop here and here, and my current here was 3.9 I believe, and that's for the R1 and 2. We just call it 3.9 or 3.92 milliamps. And the current on this bottom one is 3.5 milliamps. So we're going to do our math again and figure out our drops. So our drops for the 1000 ohm resistor, we'll call it 3.9. Take this times 3.9, and then the 560. I'm sorry, the 270 over here on the same branch is going to be just a little bit over 1.05 volts. And then we'll look down here at 560. We're going to take 560 times 3.5. And when I do that, we get a drop of about 2 volts here, I believe. Let me double check that answer. That's why we have a calculator here. So I have 560 ohms times 3.5 milliamps, and I get 1.96. So we'll call this 1.96. Very close to 2 volts here. In this other one, when I have 820 times there, I get a 2.91 here. So, and then over here on this branch where I'm looking at the 150 and the 330, we did that last time. We're just going to transfer these numbers as a 2.2 volts. And this 330 is 4.85 milliamps. And my current here, this is series, part of the whole circuit, as the total current goes through those 2 resistors. So this is the process you work through in order to figure out your voltage drops on your series parallel circuits. It's a step-by-step process. It's tedious, and there's really not a whole lot of shortcuts here, so hopefully you'll be able to work through these other circuits as we go through them. Thanks a lot. Have a great day.